Welcome back, learners, from an ad break. Now let's move on to our application questions, again based on the change of states. So now we have that two substances, we have substance X and substance Y that are given to you. And we are told that X has a higher melting point, so X has a higher melting point than Y. On the basis of this fact, say if the following statements are true or false. So if X has a higher melting point, a higher melting point than Y, let's see if these statements are true or false. So question 1A says that the particles of X have strong force of attraction between them. So the particles of X have strong forces of attraction between them. So for if X has a higher melting point, for a substance to have a higher melting point, it means even the forces of attraction must be very strong, because for a substance to melt, the forces of attraction, they need to be overcome. So for you to overcome the forces of attraction, you must add more energy. And because we've added more energy, it means the particles of X, they do have strong force of attraction between them. So this statement, it is true. So the second question B, Y is a liquid. So if a substance has strong attraction force, it can be a solid. So it can either be a solid or a liquid. Now, because we are told that X has a higher melting point than Y, it then means that Y has weaker forces of attraction or a much lower melting point, which then means that Y is a liquid. That is true. So this statement is also true. So question C, the particles of Y are closely packed together. Closely packed together. Remember, we've just said that now Y is a liquid. So the particles of Y can't be closely packed together, because for them to be closely packed together, it means the forces of attraction must be very high. And if the forces of attraction are very high, it means the melting point is also very high. So therefore, this statement, it is false. D, the particles of X vibrate at a fixed point. The particles of X vibrate at a fixed point. We know there's some matter that vibrates at a fixed point, and we know that matter is a solid. And we've just said that now, if a substance has a higher melting point, it means the attraction forces are very strong. And we know that the attraction forces are strong in a solid. And in a solid, the particles vibrate around a fixed point. So therefore, the particles of X do vibrate at a fixed point. So therefore, this statement is also true. Now, moving on. What makes matter exist in all three states? In a solid, liquid, and gas. So what makes matter to be able to exist in all those three states? So number one, the spaces. So let's start off with energy. So the energy of the particles enables certain matter to exist in all three states. Because we know that if a certain matter has weak energy, or the energy in that particular substance is very low, that substance is going to be a solid. Once we increase the energy, it is going to be a liquid, also going to be the gas. So we can also say the spaces between the particles. So the spaces between the particles, they determine if whether the substance can either be a solid, a liquid, or a gas. As we know that each and every one of those states of matter has different spaces between the particles, and also has different energies of those particular particles. Even though all of them, they are always in a constant motion, that motion is different from one state to the next state. Now, next question is there a difference between evaporation and boiling? Say yes or no and then explain. Is there a difference? Yes, there is a difference. So the first answer, to answer the question, we say yes. Yes, there is a difference. Now let's explain the difference. Now, to explain the difference, we need to know where does evaporation happen, and also where does boiling happen. We said boiling, it happens within the liquid and at the surface of the liquid. Within the liquid and at the surface of the liquid. Whereas evaporation now happens only, very important to note, only at the surface. So evaporation only happens at the surface of the liquid, whereas boiling, it is within and also at the surface of the surface. And thereafter, those gas bubbles, they escape outside the container into the surroundings. So so there is a difference between boiling and evaporation, and the difference is the location of where each of these processes is happening. One, it's within and the surface, and the other one only at the surface. Now, next question. We need to give the correct choice of the above processes. So now we are given a solid changing into a liquid, and then from there changing into a gas. And then the processes are labeled as A and B. So from the list given here, we need to choose the correct process or the processes. So A, we are told that A is solidification and B is evaporation. So we need to know that solidification, that's when now a liquid turns into a solid. So but then here we have that a solid is going to a liquid, which then means that it can be solidification. And we know that evaporation, that's when now water changes into a gas in a form of water vapor. So it can be so this is possible. Liquid to gas is possible, but then this is impossible. So therefore, it can be A. Then B, A is evaporation and B is boiling. Now we've just said that now B is evaporation. So it can be option B. But what's important to note is that the difference between evaporation and boiling, again, remember that with evaporation, it happens on the surface of the liquid, and boiling, it happens within and within the liquid and also the surface of the liquid. On top of that, for boiling to happen, the substance needs to reach its boiling point, whereas for water, it's at 100 degrees Celsius. And then with regards to evaporation, we know that evaporation can happen at any temperature, at any given temperature. You can take a glass of water and put it in the sun. After some time, that water would have decreased in volume. That's because some of it would have evaporated into the surrounding. And you would notice that the water did not reach its boiling point. So therefore, the difference between the two, also note that for the boiling, it happens within the liquid and also at the surface of the liquid. However, the liquid must reach its boiling point. Now, with regards to evaporation, evaporation only happens at the surface of the liquid. And we also need to note that evaporation can happen at any given temperature. At any given temperature, evaporation can happen. So we've said that now our option, it can be B. Looking at C, A is evaporation and B is melting. We have said that process B must be evaporation. That's when our liquid is changing into a gas. So because we on this option, we're given that B is melting, it also disqualifies it. So that means it can also be C. Now, melting and evaporation, that sounds about right. But then what is melting? Melting, that's when a solid goes from a solid into a liquid, of which this is true, our solid is going into a liquid. And then evaporation, now that's a liquid going to a gas. Also, this is also true there. So our correct option is D. Our correct option is D. D. Then our next question. Which of the following is not stated by the particle model of matter? We always need to remind ourselves of what it says. Particles are always in a constant motion. Particles are attracted by forces of attraction. There are spaces between the particles. So we always need to remember what the particle model always says. Now here, which one is not mentioned by that particular model? So molecules of a substance are in a continuous motion. That is true. That's being said by the particle model of matter. Atoms and molecules are particles of matter. That is true. The matter that you're talking about can be said to be either molecules or atoms. Water exists only in one solid phase. I have never read whereby now the particle model says that water exists only in one solid phase. But let's continue, we'll come back to that. Particles of matter are held together by forces. That we know, it's said by the particle model that the particles are always held together by the forces of attraction. And nowhere does it say that water exists only in one solid phase. Remember that water can exist in solid, liquid, and gas. And we know that water is the only substance that can exist in all those three states. So the correct answer there is C. C is not said by the particle or stated by the particle model of matter. Next question. A process that does not convert liquid into vapor. We know that moving from a liquid into vapor, that's now liquid to gas. Now, what is happening there? What is happening there? So, first of all, the process that does not convert. So, condensation is that process that changes a vapor into a liquid. So, it does not. We know that B, when we are boiling a substance, the substance can change into water vapor. We can take water as an example. When we are boiling water, that water can boil into becoming a water vapor. So that is true. Evaporation, we know that when a liquid turns into a gas or into a vapor, that's also being a liquid being turned into a vapor. So that's also true. We also know that when we are heating or when we are adding energy into the substance, after a certain amount of time, we are going to change that liquid into a water vapor. So we're going to do a phase change, where now the liquid is going to turn into a gas or into a water vapor. But the only one that is not true is this one, condensation. Because condensation, it is changing a gas into a liquid. It's basically the opposite of what is being asked here. Now, trying to apply all that we've learned into this particular diagram that we are given here. So the following graph shows the changing of ice, and then we need to study the graph and complete this graph. So we are given that we have matter A, we have matter C there, and we have matter E there. We need to label and complete this entire graph. So we know that by looking at this shape, it's rigid, and there are spaces, there are small spaces between them, so it must be a solid. Now looking at B, before coming to these two processes here at B, going to C, now there is a phase change. Remember that the phase changes are happening at these points there. There is a phase change there. Now that particular matter has spaces, it's not rigid, and the spaces are slightly bigger than the spaces in a solid phase. So therefore, this must be a liquid. And if this is a liquid, then the last one there, by merely looking at the shape and looking at the spaces between the particles, this is a gas. This is a gas. Now, the processes that are responsible for the phase change. When we are now going from a solid into a liquid, what is it that we are doing? And also, when we are going from a liquid into a gas, what is it that we are doing? So, first of all, when we are moving from a solid into a liquid, we know that it is melting. So this process here is called melting. And then when we are moving from liquid to gas, we know that it is evaporation. Now going backwards from gas into a liquid, we know that this is condensation. And then from a liquid into a solid, we know that for us to get a solid from a liquid, we must freeze. So this is freezing. So these are our processes. We have our freezing that is going from liquid into a solid, condensation that is going from a gas into a liquid, and we have melting going from a solid into a liquid, evaporation going from a liquid into a gas. So let's take an 8 break so that we can go and process this information. I'll see you just after this.